Hi there, welcome to a video tutorial that continues our discussion about transforming functions. At this point, we've talked about those 5 basic functions: the quadratic, cubic, square root, the absolute value, and the hyperbola. We've translated those things, so we've moved them left and right, up and down. At this point, I'm going to start talking about reflections. So you're going to see how reflection changes the graph of those functions in this video lesson. What I've done is just graphed the square root function as well as the square root function with a negative in front. So when you do that, you'll see that this blue graph, this is your square root function, and this red graph, this is your negative square root function. So don't be confused. Most people say, oh, you can't take the square root of a negative number, and those people are right, but I'm not taking the square root of a negative number. I'm taking the square root and then making it negative. So what I'm doing is I'm taking my y values that I got when I square rooted an x value, and I'm making them negative. So it makes sense that I took this graph and reflected it over the x-axis, right? I'm now, all of the positive y values that I had are now negative y values. That's the first little demo I want to show you. Second one involves taking that base root function, but this time I'm going to put a negative value inside my square root sign. Okay, when I graph those two functions, you see this is my base function, and this guy here is my reflected function. So instead of flipping over the x-axis, I'm flipping over the y-axis. Now this makes sense because picture, if I took positive x values such as 1, 2, 3, and so on, you'd be taking the square root of negative 1, 2, 3, and so on. And we know that those x values are not in the domain of this function. So it makes sense that all of our x values occur in the negative quadrants. Okay, so if I take negative 1, for instance, and I substitute it into my negative x rooted function, I would end up taking the square root of a positive number. So that makes sense that my y values appear over here once I substitute negative x values in. Okay, so I just want to quickly summarize the reflections that we just saw. So in general, if I take a negative sign and I multiply by a function, any function, not just the root function, you end up with a reflection over the x-axis. Sometimes this is called a vertical reflection. If we put that negative inside the function, you see a reflection over the y-axis. And sometimes we call that a horizontal reflection. And that's what we just saw with these two graphs here. Okay, so I want to go over a quick example here that requires you to state the transformations from the base graph as well as graph the new function. So the base graph I've shown you here, this is the square root of x. We know what this base graph looks like. And what I'm doing is I'm reflecting, and I'm not going to spoil what happens, but there are two reflections here, as well as some sort of translation. So I want to demonstrate how you state those transformations as well as graph the transformations given the base graph. So the first thing that you can really pick out here using our summary that we just talked about is if I put a negative on the outside of the function, if I multiply by a negative, which I'm doing here, you're going to see that there's a vertical reflection. So you can just kind of imagine if I flip that function over the x-axis, you'd see something like this. So why don't I just put that in red? Right, that's our reflected function. You also see here there's a negative sign inside the function. That tells me that not only do I reflect over the x-axis, I also reflect over the y-axis. So that takes care of my two reflections. But there's also another transformation involved here, and this is something that we talked about in a previous video tutorial. I've got this plus 9 here. Remember, based on our conversation, if we're adding a number inside the function, that tells us that we're moving to the left by 9. But just to confuse you here, this is actually not the case. And the reason is we have to factor out this negative, or we're going to skew our translation. Right? So if we take what's inside the brackets here and we just factor out that negative, we still keep it in the square root, but we're going to take it out of each term. You're going to see that you're actually moving to the right by 9. And that's because this form that the original expression is written in, this is a simplified form, as if I distributed this negative into the brackets. So you got to look out for these sorts of functions because they happen everywhere. And if you're not careful, you're going to skew your translation, and your teacher or whoever is giving you this problem is going to get really mad at you. Okay, but once I've performed my reflections, I can next just move everything to the right by 9. So you can see that I've just shifted this graph entirely over by 9 units. So all of those points are moved by 9 compared to where they were originally. So from this we can conclude we've reflected our function over the x and y axes, and we've also translated to the right by 9 units. But something I want to mention, just be really careful. Always apply reflections before translations. So don't take your graph and move it to the right by 9 and then reflect. It's always a good idea to just perform your reflections first. You're going to see that moving forward as we start introducing stretches and compressions especially. One more quick example, stating transformations from base graph as well as graphing. Very similar to what we just did, but I've introduced these different graphs. This guy here is your hyperbola graph. I've shown you the base function below here. So remember, same thing. If we're talking about reflections, this guy here is inside the function. So we know that that's going to be a reflection over the y-axis. But we have to factor that negative out if we want to talk about our translation. Remember, if we don't factor out that negative, we're going to skew our translation. So we know that this thing's going to be reflected over the y-axis, and it's also going to be shifted to the left by 3. You might notice that if you were to reflect this thing over the y-axis, that would be what it would look like if I flipped it over the y-axis. Why don't I just color that red for you just so you can see the difference. You can see that if I instead reflected this thing over the x-axis, you'd actually get the same graph. And that just has to do with the fact that I can really take this negative and I can move it on top, in front, or the bottom. It doesn't really matter where I place that. Once I perform that reflection, I can now shift to the left by 3 units. So this is going to be very approximate, but I'm going to be approximately here. Okay, so I've taken that vertical asymptote, remember that word where the function is not defined, and I've shifted it to the left by 3 units. So this would be a reflected and translated graph. Okay, this next example, same thing. Remember, just be careful, make sure you factor out that negative first, and then you can start applying your reflections. You can see I've got 2 reflections, one over the y-axis, one over the x-axis, and I'm also shifting to the right by 4. I'm just going to demonstrate something interesting with this absolute value function. If I flip over the y-axis, which is what this negative here tells me to do, you're going to see there's actually no difference. And that makes sense. If it's symmetric about the y-axis, there's no difference when I perform that reflection. However, once I perform the reflection over the x-axis, this does make a difference to my original graph. Okay, so that's our reflected graph. Now we also have a shift to the right by 4 and up by 2. So once I've performed that reflection, I can shift to the right by 4 as well as up by 2. So this would be my new translated and reflected graph. That brings me to the end of this video tutorial. Next lesson where we introduce stretches and compressions, and then we start combining all of these things together.